All right, good morning. So, we're going to do another video today about stainless steel. We're going to do a short series within our video series about Martensitic Stainless Steels. And today will be video number 1, part 1, on Martensitic Stainless Steels, which we hope you find useful. Martensitic Stainless Steels can be hardened by conventional heat treatments. You may be familiar with heat treating carbon and alloy steels. If not, in a very simplified terms, you heat the material up to temperature where the structure becomes austenitic, and then cool it at a rate fast enough, and pow, presto, martensite is the resulting structure. Cool slower and the steel would become ferrite and iron carbides. With the faster cooling, the carbon atoms do not have the time to form the carbides and become stuck. Martensite is considerably harder, stronger, and more brittle than the other structures that we have touched on in previous videos, the austenite and ferrite types. Hardness achieved goes up with increasing carbon content of the alloy. Here in part 1, we will be discussing alloys with a carbon content of 0.15% and less, which yield a hardness of 45 Rockwell C and below, depending on the amount of carbon. At their maximum hardness, these alloys are also at their most resistant to general corrosion, but tend to be brittle. To get the combination of corrosion performance and useful strength and hardness, the material is again heated to create a tempered martensitic final structure. Lose the brittleness without sacrificing too much hardness and corrosion resistance. These martensitic stainless types also lose toughness and impact at temperatures of 0 to 100 degrees Fahrenheit on the type and heat treatment. Wow. So now we're balancing the hardness, strength, and corrosion performance we need. Sounds complicated, right? Well, it is. Glad we're not doing that here. Just the basics for now. Anyway, let's get into some of the types and grades in this category. Type 410 at 11.5 to 13.5% chromium has a carbon maximum of 0.15%. Depending on the actual carbon content, the maximum hardness it can achieve varies from the low 30s to low 40s RC. Various specifications restrict the chemistry or require a range of hardness in standard tests to assure the higher hardness versions when needed. AMS 5612 for aircraft applications is one that requires higher hardness in standard test. Type 403 is a very similar chemistry and known as turbine quality, originally used for steam turbines, valves, and other component applications where strength and oxidation corrosion at operating temperatures above 800 degrees Fahrenheit. Type 416 has the same 0.15% maximum carbon and chromium at 12 to 14%, but has sulfur added to improve machinability. Often, it has lower actual carbon content and typically is used at lower hardness than 410. Sulfur has negative effects on toughness and corrosion resistance. This grade is used where the added machinability offsets a loss in corrosion performance and mechanical properties. 416 is used in a wide variety of applications, such as screw machine parts, pumps, and valves. Now, as we have said before, specifications often restrict the chemical composition further and add requirements for the material far beyond just the chemistry. So remember, check out our latest in our Steel Series videos here. Please like the video and remember to subscribe here. Stay tuned for part 2, higher carbon and higher hardness Martensitic Stainless Steels. This is Michael with Michelin Metals. Out.